Hello everyone, welcome to the discussions on the past year questions. This video we shall take a look at the further mechanic, paper 3, October-November 2023, paper 31. Let's take a look at the first question. Two uniform smooth sphere A and B of equal radii have masses m and 2m respectively. The two spheres are moving with an equal speed u on a smooth horizontal surface. When they collide, immediately before the collision, A's directions of motion makes an angle 60 degrees with the line of centers, and B's directions of motion makes an angle theta with the line of centers. See diagram. The coefficients of restitution between the sphere is E. After the collision, the component of velocity of A along the line of the center is V. B move perpendicular to the line of the center. Sphere A now has twice as much KE as the sphere of B. So for these questions, before we do it, we need to have a diagram before and after. So before the collision, that is the M for the mass of A. This is the theta, 60 degree. That is the U. Then the B is moving in these directions. This is the theta. Then this is the U as well. This is the 2M. After the collision, B will go perpendicular to the line of center. This is the VB. And they say that the component of the velocity center is V. That means that the horizontal is V. But the A might going this way. Okay. Actually, the A might going this way. So with the angle alpha. Okay, so we will assume that there's the A after the collision, A is moving to these directions. Okay. A is moving to these directions. But my assumption may be wrong because this is just an assumption. So the assumption over here is that I assume that A go this way because A might go this way. A might go this way. And this will be the V. This is the alpha. So it's possible. So what we can do is that we just need to choose, make a decision to choose one of it. So over here, I would choose the A directions still remain unchanged. And we solve it. So this is the VA. But the horizontal component is V. Okay, which means the VA cos alpha is actually a V. Okay, so this is something you need to know. Now, first part of the question, show that the V is equal to the half U for cos theta minus 1. So what you can do is you just consider the horizontal component, and using the conservations of momentum, you have M U cos 60. Consider the horizontal component only, plus the 2M of negative U cos theta is equals to the M VA cos alpha. But I told you just now VA cos alpha was V. VA cos alpha is V. So we just need to write down this one as MV will do. Cancel all the M. And you know that the V is equal to the half U minus the 2U cos theta. And when you factorize the half U out, you get a 1 minus the 4 cos theta. So you can see that my answer and the answer given here is not really the same. What is the difference over here? The difference is actually these two value is swapped. So that means my assumption was wrong. Okay, my assumption was wrong. That means the V is supposed to be reversed. Okay, the directions of A is supposed to be reversed. So from here, I know that my assumption was wrong already. Then I just need to change this diagram into this. That is the alpha, that is a V. So when I solve this part, I supposed to use a negative V. So this will be a negative V. Therefore, the V will be 4 cos theta minus 1. Okay, shown. So this purpose of the questions over the solutions over here is actually the purpose to tell you that the A has reversed the directions after the collision. Now we want to find the value of the cos theta. So we will consider the vertical component. So for the vertical component for the B, before and after are the same because the vertical component is not involving collision. So you have a U sine theta equal to the VB. You can write VB is equal to the U sine theta. Then at A, if you consider the vertical component as well, then you have a VA sine alpha. VA sine alpha before and after are the same. VA sine alpha equal to the U sine 60. It will be equal to the 3 over 2U. And VA cos alpha, the horizontal component, just VA cos alpha, just now we know that the VA cos alpha is a V and V is the answer here. So we just copy down. Okay. So we need to have a VA. Because I'm planning to use this information, the KE. So when the KE is actually means that the K half M VA square is equal to 2 times of the half of 2M of VB square. So I need to have a VA square and VB square. In order to get VA square and VB square, I need to find the VA by using the formula over here, these two. Okay, how do you get VA square? So VA square is actually same as the VA sine alpha. You square it plus the VA cos alpha. You square it. You don't really need to know the value of sine alpha and cos alpha. So over here, you will get this as the 3 over 4 U square plus of 4 cos theta minus 1 square. Take the 1 over 4 U square out, then you will get 3 plus the 16 cos square theta minus the 8 cos theta plus the 1. Then you get 1 over 4 U square of 16 cos square theta minus the 8 cos theta plus 4. Okay, so you can see that actually the 4 can be cancelled off. That means U square, you can see that you have a 4 cos square theta minus a 2 cos theta plus 1. That will be my VA square. And for the VB square, it's just a U square sine square theta. Okay. So we are ready with the V square, VA square and VB square. Now we can apply the result that the conservation of energy. Given that KE at A is twice as the KE at B. So it will be half M VA square is equal to 2 times a half of 2M of the VB square. So it will be cancel the half M, cancel the half M. You will get VA square equals to the 4 VB square. What is the VA square? Just copy down from the result here. You get a U square 4 cos square theta minus 2 cos theta plus 1. VB square is a U square sine square theta. Cancel the U square. Change the sine square to become 1 minus cos square. Okay. Then the 1 can be cancelled off. Then you have 5 cos square theta minus a 2 cos theta. So your cos theta, 5 cos theta minus 2. Hey, I'm so sorry. I forgot to times 4. Okay, I make a mistake. This one is a 4. Okay, there's a 4 here. I forgot the times 4. So this one, it will be wrong here. So this one, it will be 4 1 minus cos square theta. And if you go join together, you will have 8 cos square theta minus a 2 cos theta minus a 3 equal to 0. Factorize it, 4 cos theta, 2 cos theta. Then you get negative 3 plus 1. Your cos theta equal to 3 over 4, and your cos theta equal to the negative half. The angle is a cube, so therefore you have to ignore this. No, sorry, you ignore the negative. A cube angle, the theta is a cube, so you ignore the negative value for the cos theta. So therefore your answer for the cos theta is 3 over 4. That's it. That is the answer for the question B. Now, yeah, done. We're only looking for the cos theta. Now we're moving to the value of E. To find the E, because the E is actually involving negative of the negative V minus a 0, is actually involving horizontal component. Then this one, it will be U cos 60 plus the U sine U sine theta. Yeah, U cos theta. So U cos theta. So I already have cos theta because cos theta just now is 3 over 4, right? But I do not know the V yet. So over here, I cannot use this formula yet to find the E. I need to find the V first. Okay, so over here, we just find the V first, then we can only find the E. So the V, where's the V? The V is actually this. This is the V. So V is equal to the half U. 4 cos theta minus a 1. So you will get U. V is a U. So your E is equal to the negative of the negative U minus a 0 over the U cos 60 plus the U cos theta. And this will be a positive. The U all can be cancelled. Okay, all the U can be cancelled. So this it will be a 1 over the half plus the 3 over 4. Then just press the calculator. You will get the answer as 4 over 5. Just like that. That will be the answer for the C. Okay, and after that, moving on, we are going for the question number 2. A ball of mass 2 kg is projected vertically downward with a speed 5 meters per second through a liquid. At time t second after projection, the velocity of ball is v meter per second and its displacement from its starting point is x meter. The force acting on the ball are its weight and the resistive force of magnitude of 0.2 v squared. Express v in terms of d. Okay, so first of all, by applying Newton's second law, if you consider the vertical motion, you will have the mg minus the resistance force is equal to the ma. Your mg, it will be 20 minus the resistance force, it will be 0.2 v squared given in the questions. So this one, the m is a 2. The a is over here because they want v in terms of t. So the a, we change it dv dt. So that means the dv dt is actually equals to the 10 minus the 0.1 v squared. Okay. Then by applying the so-called separable variables, I prefer to not to involve decimal. I make it become fractions. Then I will have this as the 10 divided by 100 minus the v squared dv integrate equal to integrate the dt. This one integrate directly, you get the d plus c. This one, I need to do the partial fractions. You can actually direct integrate from the formula booklet MM19. Okay, you can use formula booklet MM19 to integrate it, but I will use a partial fraction to split them. I will use a partial fraction to split them. This one will become the 10 minus v, and then 10 plus v. Then this one, it will be, so this one I put a plus, I get a 20. So it's a 1 over 20. Okay. One over 20. 1 over 2 only, not 1 over 20. 1 over 2. So I just direct do the partial fraction directly. Then I integrate this. I will get this one as a negative ln of the modulus 10 minus v plus the ln of 10 plus v is equal to d plus c. So join together, you have this. If you apply the formula bullet MM19 directly, you can get this answer straight away. Then we want to find the c. How to find the c? Initially the speed is 5. Okay. Then the time t is 0. So when t equal to 0, your v is 5. That means you have a half ln of 15 and 5 equal to c. So your c is a half ln 3. Okay. Then replace it back to the equation just now. Join the half together. You get half of ln, this one minus, and then you'll get divide. Okay. Minus ln 3, you will divide by 3. That means it will be division. 10 plus v divided by 3 of 10 minus v. Then bring the half, go to the other side, you get 2t. Bring the ln to the other side, you get e power 2t. Okay, so this one, it will be 3, 10 minus v. Now, however, we know that these questions are whenever we have the answer of exponent in terms of d, usually we want the negative power. We want the negative power. Usually we want negative power because for these questions, if I'm not mistaken, usually they will ask you to find something when the value of the d is very large. So over here, we will change the d become power negative. So we change the power to become negative, then you get this reverse, make it become reciprocal, then you will get power negative 2t. Then now you have a 30 minus a 3v equal to the 10e power negative 2t plus the ve power negative 2t. All the v join together. All the v join together. Then you will have this as the 30 minus the 10e power negative 2t equals to the v of 3 plus e power negative 2t. The v. Therefore, your v is equals to the 10 3 minus e power negative 2t divided by the 3 plus e power negative 2t. Done for this answer for the v. Okay, then move on with the part b. What happened when the t, what happened to the v for the large value of t? Okay, so that means when t is going to infinity, approaching to infinity, that means the e power negative 2t will be approaching to 0. So therefore, your v will be approaching to the 10 multiplied by 3 minus 0 over the 3 plus 0. That will be equals to a 10. That will be the answer for the b. Okay, and move on. Question number 3. Okay, now we take a look at question number 3. A uniform square lamina of side 2A and the weight W is suspended from a light inextensible string attached to the midpoint E of the side AB. The other end of the string is attached to a fixed point O on a rough vertical wall. The vertex B of a lamina is in contact with the wall. The string EP is perpendicular. EP is perpendicular to the side of AB and makes an angle theta with the wall. The string and the lamina are in vertical plane perpendicular to the wall. The coefficient of friction between the wall and the lamina is half. Okay, so over here, let's just put the center of the mass is over here. Then this is the weight, W. Okay. Then this is the contact point. So you will have a normal contact, normal reactions on P. And your frictional force, they say that given at the vertex B, given that the vertex B is about to slip up the wall, so it's about to go up. If it's about to go up, then your frictional force will go down. Your frictional force will go down. And since it's about to slip up, that means you are having a limiting equilibrium over here. So that means your FB will be equal to the half RB. Okay, so this is what we're having. And the tension is over here. Okay, so we want to find the value of tension theta. Okay, so now we will need to resolve the forces vertically and horizontally. Since they're in equilibrium, usually we need to resolve the forces vertically and horizontally. So if you resolve the forces vertically and horizontally, for vertically, then you will get T cos theta is equals to the W plus the FB. Okay, so this is what we have. And since the FB is equal to half RB, we just write this one as the half RB. Okay, and I call this one equation number 1. And if you resolve the forces horizontally, you will get T sine theta is equal to the RB. So you can see that the RB and the RB here, we're going to replace it because the FB and RB is the symbol that I give myself. So I need to try to eliminate them as soon as possible. So over here, I call this one 2. 2 into 1. I have T cos theta equal to the W plus half T sine theta. Bring the T go to the other side. You have T cos theta minus a half sine theta is equal to W. Okay, so this is what we have. I call this one equation number 3. We will take the moment. Where should I take the moment about? Like I said just now, FB and RB is the symbol that I create myself. We try not to involve these two. So the best is we take the moment about the point B. Take the moment about the point B. Then if you take the moment about the point B, you can ignore this. So you have only this weight W. We need to find the distance here. So be careful, the distance over here is not necessary, must be exactly, it's not exactly that this point will be exactly same level as the B. Okay, so with this one have to be careful. Okay, then for the D, as for the D, you can see that the perpendicular distance for the perpendicular distance for the T, it will be here. This is the perpendicular distance, so it will be TA. Okay, this will be the perpendicular distance because it's perpendicular. Then this one, maybe I shouldn't draw the W over here like this. Is quite easy to confuse. Maybe I should draw the W like this. Then you can see that the distance here is not really a 45 degree, and then you use the Pythagoras theorem to get set to A. It's not necessary to be set to A. Okay, so with this one you have to be careful. So to be safe, usually we will not going to find the distance for this one. This one just now, this distance was the distance number 1. This distance number 2. Distance number 1 is quite obvious. Distance number 1 is A. Distance number 2. So for this case, usually we were not going to find the distance number 2 directly. So you can actually resolve the forces of the W, to become W. You make it like this. Make it become, this force is a W cos theta. Make it, this force will be a W sin theta. Then from here, you have one force, you make it become 2 forces. Okay, make this become 2 forces. And the perpendicular distance of W cos theta to the point B is A. And the perpendicular distance of W sin theta, perpendicular distance to the point B, is also A. So you can do it this way. Okay, so one force of W, we split them to become 2 forces. We resolve them become 2 forces. So over here, take the moment about the point B, you have dA. You can see that if you resolve them into 2 forces about the point B, D is going clockwise. W sin theta and the W cos theta, they both going anti-clockwise. So dA will be equal to the W cos theta multiply A plus the W sin theta multiply A. So you can cancel all the A, factorize the W out, you get D is equals to the cos theta plus sin theta W. That is equation number 4. We are looking for theta, tangent theta. We do not want to find D and we do not want to find the W at the moment. So we can see that from these 2 equations, the easiest way to find the theta is to take the equation number 3 divided by equation number 4. Then you will have T cos theta minus half sin theta divided by the T is equals to the W divided by the cos theta plus sin theta W. So the W can cancel, the T can be cancelled. From here, we will end with this relationship. Cos theta plus sin theta multiplied by cos theta minus a half sin theta is equal to 1. Expand cos square theta plus the cos theta sin theta minus the half cos theta sin theta minus a half sin square theta equal to 1. So over here, we can actually, these 2 can combine. Combine together, you get a half. So you have a cos square theta plus a half cos theta minus cos theta sin theta. Then minus a half sin square theta equals to 1. So we need to find tangent. So in order to find tangent, actually, we just need to divide everyone by cos square. Divide everyone by cos square, you get a 1 plus this one, cosine divide cos square, you will get sine over cos, you will get half tangent. This one you will get half tangent square. This one you will get secant square. And as we all know, secant square is actually 1 plus tangent square. Okay, so you get this. One and one can cancel off. So at the end, you get, I think I times 2 first. I make it theta minus tangent theta minus the tangent square theta equal to the 2 tangent square theta. Then I have 3 tangent square theta minus the tangent theta equal to 0. Factorize the tangent theta out. Minus 1 equal to 0. Therefore, you have tangent theta equal to 0 and the tangent theta equal to 1 over 3. Tangent theta equal to 0 need to be ignored, because if the theta equal to 0, that means your tangent theta equal to 0 means your theta is a 0 degree. 0 degree means you will not going to have an angle here. So that's it, done. We have found the tangent theta. That is the answer for the part A. Oh, this one only have one question, no part B. So we are done. And moving on, question number 4. Okay, now we take a look at question number 4. A light elastic string has natural length 8a and the modulus of elasticity 5 mg. A particle P of mass m is attached to a midpoint of the string. The end of the strings are attached to the point A and B, which are a distance of 12a apart on the smooth horizontal table. The particle P is held on the table so that the AB equal to BP equal to L, same distance. And the particle P is released from rest, and P is at the midpoint of AB. It has a speed of square root of 80 ag. Find L in terms of A. So that means if they change into here, and when the P reach here, originally your U is a 0, and when you reach here, your V, it will be square root of 80 of ag. So this one is involving speed. You can see that the energy KE increase. That means the EPE will be lost. Okay, no GPE involved. So right here, we can just straight away start from. Okay, now before that, we need to know the original length for the string is 8a. The extension at the very beginning is 2L minus 8a. Then when you reach to this, become a straight line. This is a 12a. 12a, the extension will be minus 8a. 12a minus 8a, it will be a 4a. So this will be a 4a. Okay, let's just write 4a. Okay, and the lambda is a 5 mg. Okay, so with this in our the information have listed down, we can start to do the conservations of energy. So you have a EPE loss is equal to the KE gain. So EPE loss will be the lambda. Lambda is lambda of x1 square minus x2 square divided by 2L of the V square minus the U square. Okay, so your lambda is a 5 mg. This one is a 2L minus 8a minus the 4a square divided by the 2m. Go to the half m of the 80 ag minus a 0. Cancel the m, cancel the half. So you get over here I will have 5g This one expand, you get a 4L square minus the 32AL plus the 64A square minus the 16A square divided by the 8A is equals to the 80 AG. Okay. So you can see that the G can be cancelled off. I plan to multiply the 8A, go to the other side. But before that, the 5 and the 8D can be cancelled off. So the 5 cancel, the 8D cancel, you get 16. Then you have a 4L square minus a 32AL plus the 64A square minus a 16A square is equals to 16 times 8. 16 times 8, 128A square. All of them can be divided by 4. I divided by 4 first. This one minus together, 64A square minus 16. 48 divided by 4, 12A square. 128 divided by 4, 32 A square. And this I get L square minus the 8AL minus the 20 A square equal to 0. Factorize it. Then you have a negative 10A plus the 2A. Correct. So your L is equal to 10A. Your L is equal to negative 2A. Obviously, the negative 2A need to be ignored because the L is a length. So your answer is that your L must be a 10A. Okay, just like that. Done for the part A. Move on. Part B. Find the initial accelerations of the B in terms of G. So the initial acceleration means you have to go back to the diagram. Initially, they are symmetrical. This angle and this angle are the same. We already know that the L is a 10A. Then this one, we cut them into half. You have a 6A here. Okay. So from here, you can view the triangle. 6, 10, and what is the value? 6, 10, actually, this one is the, okay, so maybe from here, from the triangle, we can have sine theta is equal to the 6A over 10A. That it will give you 3 over 5. Then from here, you can build the triangle again. 3 here, 5 here, there will be a 4. Okay. So if you consider the forces horizontally, you will have 2T cos theta. This is the tension T. 2T, they must have an equal tension because it's the same string and it's a midpoint. So 2T cos theta, it will be equals to the MA. It will be equal to the MA. The A is acceleration. Okay, it will be equal to MA. A is accelerations. So I think I will use the X of double prime over here to represent the accelerations. Okay. So for these questions, the M, we do not know the M, but the tension, each tension, the tension will be the lambda X over L. Okay. But this tension is only for 1. So 10A, originally 8A. So 8A divide 2, you have 4A. 4A stretched to 10A. That means your extension will be your lambda is a 5 mg. Your extension is 4A stretched to 10A, you have 6A. Your L is only 4A because we only take half, consider half of it only. Okay. So it will be 2 multiplied by 5 mg multiplied 6A divided by 4A. Cos theta is a 4 over 5 is equal to the MA. the accelerations. M can be cancelled. Then 4, 4 cancel, 5, 5 cancel. Then your accelerations will be 12. A also cancel 12G. Yeah, that's all. So that will be your answer for the part B. Okay, moving on, question number 5. Okay, now we take a look at question number 5. Question number 5. A particle P is projected with a speed u meter per second at an angle theta above the horizontal from point O on the horizontal plane and move freely under gravity. During this flight, it passes through the point which is horizontal distance of 3a and the vertical distance of 3 over 8a above the horizontal plane. It is given that tangent theta is 1 over 3. So over here, we started from tangent theta is equal to 1 over 3. We built a small triangle here. So 10. So they give you x, they give you y. What we need to do is just to use the trajectory equation. Y is equal to the x tangent theta minus the gx squared over the 2u squared cos square theta. Okay. Then at the point 3a, 3 over 8a. So you will have 3 over 8a equals to the 3a tangent theta minus g. X is a 3a divided by the 2u squared cos theta. Cos theta is a 3 over sub 10. Okay, simplify it. You will get 3 over 8a equal to a minus the 9 ga squared over the 2u squared of 9 over 10. I will get 5g a squared over u squared is equals to the 5 over 8a. Therefore, the u squared is equals to the 8ga shown. Just like that for the part A. Done. Now, we move on. A particle Q is projected with a speed v at an angle alpha above horizontal from O. At the instance when the P is at the highest point, the particle P and Q both land at the same point on the horizontal plane. Oh, okay. The meaning is that we have a particle P projected when the P reaches the highest maximum height. Then the Q start to project. You start to project the Q with the angle alpha. Then they say that after this, they meet at the same point. They land at the same point at the same time. Okay. So that is the meaning of it. So what we need to do is we want to find when we will need to project the particle Q. So the particle Q, it will be the highest point of the P. So means I need to find the P, YP, horizontal displacement, vertical displacement. Vertical displacement is a u sine theta d minus a half gt squared. So I have the yp dt. I get the u sine theta minus the gt for the dyp dt equal to 0. Then I get the d is equal to the u sine theta over g. We already know the u square is equal to the 8ag, but I think try not to involve this one first, because if I involve 8ag, square root of 8ag, it will be looks very complicated. This is the time where this is actually the half of the time. if it times 2, with times 2, that will be the time that for B is moving from here to here. This is the T. Then from here to here, this is another T. So if it times 2, total time will be reaching the ground. Okay, but no need, just for your information only. Then for the distance, I need to know the distance as well. Distance. So for XP is equal to the U cos theta T. Okay, so if we double the time, the range is 2 times the time, Okay? The range, it will be XP equals to the U cos theta multiply the 2 of the time that you have found. So you will have a 2U square cos theta sine theta over G. Over here we have a U square. That will be easier for us. Now we can change the U square become 8AG. So we have a 2 multiply 8AG cos theta sine theta. Oh, I have the cos theta. Cos theta sine theta is how much? Cos theta is just now the diagram. Cos theta is a 1 over sub 10. 1 over sub 10. Sine theta is 3 over sub 10. Then if you divide it by G, so if you cancel everything, you will get this one as the 16 times 3 over 10. (24 over 5). A. This will be the range. This is the range. That means this will be the distance that the Q need to be traveled when it lands on the ground. Then since I know this already, we can actually, okay. Now at Q, we have the XQ is equals to the V cos alpha T, and the YQ is a V sine alpha T minus a half GT squared. The time that the Q will travel is this much. Q need to travel this much of time because when the P at the highest point, P still need to travel this much to land, but Q just need to spend this much of time to land the ground. Okay, so Q will start a little bit late than P. So when the T is equal to the U sine theta over G, okay, your XQ will be the 24 over 5A. Okay, and then your YQ will be a 0. These are the information. So from here, you will get the 24 over 5A is equal to the V cos alpha multiplied by U sine theta G. So you get the V cos alpha is equals to the 24 AG divided by the 5 U sine theta. Okay. Then when this one I call it number 1, I call this one number 2. Okay. So this one from number 1, I get this. From the number 2, I will get 0 equal to the V sine alpha T minus a half G T squared. Factorize the T out. So T equal to 0, you ignore it. This is at the very beginning. Then T is equals to the 2V sine alpha over G. This 2V sine alpha over G, the time that you have here will be the same as the time here. So you let them equal. then you will get u sine theta over the sine alpha over the g. Cancel the g, then you get the v sine alpha is equal to the half u sine theta. Okay, this is the v sine alpha. We want the v. We want the v. So this one is equation number 3. This one will be the equation number 4. Okay, so we know that the v square, it will be same as a v cos alpha square plus the v sine alpha square. So by taking the number 3, you will get 24 ag over the 5 u sine theta, you square it, plus the half u sine theta, you square it. So this one, your 24 square, 1576. So you have a 576 a square g square divided by 25 u square sine square theta plus the u square sine square theta over the 4. Now we change the u square to become 8 ag sine square. Sine square was sine square is a 1 over 10. 1 over 10. This one is a 8 ag 1 over 10 divided by 4. So simplify it. This is the v square. So if you simplify it, you get 576 times 10 divided by 25 divided by 8. You are having 144 over 5 ag plus the 8 divided by 40. That will be 1 over 5 ag. Then your v will be equal to 145 divided by 5, 29 ag. Square it. That will be your answer for the b. That will be your answer for the b. Yeah. Okay. Done. Okay, now we take a look at question number 6. Particle P of mass m is attached to one end of a light inextensible rod of length. An identical particle Q is attached to the other end of the rod. The rod is smoothly pivoted at a point O on the rod, where OQ is equal to X. The system of the rod is, and the particle rotates about the O in the vertical plane. So you can see that this is the meaning of the diagram. Okay, so you are having that this is the pivot. Pivot, I don't need to shade the region. So this one is the O. Then you have a point Q is over here. You have a particle P is over here. Okay, so both of them, they are having the mass m. The distance here is 3x. The distance here is x, and another distance here is a 3a minus x. Okay, this distance is a 3a minus x. Okay, at the instant where the rod is vertical, so when the rod is vertical, the particle P is moving horizontally with the speed u. P is above q. P is above q, so P is over here. So this is a u. Then this one is a uq. Okay. We do not know the value of uq, but we know that this is a u. Okay. Then for the, when the rod turns around 60 degrees from the vertical, the speed of P is do 2 sub AG. So when it turn to become this, when it has become this one is 60 degree. This one is 60 degree. This will be the VQ. This will be the VP. But the question giving you that the VP is a 2 sub AG. So we just write 2 sub AG. Okay. That we need, there's a changes of speed and the changes of height. So we can use conservations of energy. Show that the speed of Q when the rod has turned through the angle 60 degree from the vertical is this much. Okay. Know the speed. So what is the relationship of the speed of Q and the speed of P? Okay. What we can say is that when the because for this one is a circular motion, circular motions, we have angular speed and we have tangential speed. Angular speed is, we use omega to represent. Tangential speed is V. So the relationship between tangential speed and angular speed is that the V is equal to R omega. So you can see that the tangential speed depends on the radius. Okay. So by right, because they are using the same rod, by right, the speed are the same. But the speed are the same. What we meant the speed is the same is the angular speed are the same. Okay, not the tangential speed. The angular speed are the same. So over here, what we can do is that we start from angular speed. Angular speed of P and Q are the same. The omega P is equal to the omega Q. Okay, this formula is involving sub AG, so we can use the V over here. That means the VP over the radius. The radius of the P is 3A minus X is equal to the VQ divided by the X. So your VP just now given 2 square root of AG. And this one divided by 3A minus X is equal to the VQ divided by X. So therefore your VQ is equal to the 2x square root of AG divided by 3A minus X. That will be the answer for the part A. Then find the X in terms of A. Find X in terms of A. So what we can do just now we mentioned about conservation of energy, right? Here, maybe the energy conservation of energy may be not suitable. Okay, we can try to resolve the forces at the point here. Resolve the forces at the point here, because they mentioned that the tension of the two parts of the rod OP and OQ have an equal magnitude. That means they're having the tension T. This tension T and the tension T are the same. So we consider the tension first. At Q, the tension is T minus this one is a mg, minus mg cos 60 is equal to the mvq square over the x. So you get T is equal to the half mg plus the mx vq square. VQ square, just take the VQ over here. Just take the VQ over here. So VQ square, you have a 4x square AG divided by the 3A minus X square. Okay. Simplify further, you get half mg, then plus the 4 magx over the 3a minus x squared. Okay, so we're having a first equation like this. Now we go for B. We have B, we have d plus mg cos theta. Is equals to the mvp square over the 3a minus x. So it will be d is equals to the negative half mg plus the m over 3a minus x. Your b is a 4, vp is a 2 third ag. So if you square it, you get 4 ag. So this one you will get this as the negative half mg plus the 4 mga over the 3a minus x. Okay, so that will be the equation number 2. Equation 1 and equation 2 are the same. So we'll be having half mg plus the 4 mag divided by the 3a minus x squared is equal to the negative half mg the 4 mga over the 3a minus x. So the mg is very annoying. So we just cancel the mg. So we have these two combined together, you will get a 1. So you have a 1 plus the 4ax over the 3a minus x squared is equals to the 4a divided by 3a minus x. So I multiply everyone by 3a minus x squared. So I get 3a minus x plus the 4ax equals to the 4a multiply 3a minus x. Expand 9a squared minus a 6ax plus x squared plus 4ax equal to 12a squared minus a 4ax. So you will get the x squared plus the 2ax minus the 3a squared equal to 0. Factorize it. X plus 3a, x minus a. You get x equal to negative 3a and x equal to a. This one ignore. There you have it. We found that x equal to a. Just like that. Done. Okay, so obviously we have used the resolving forces at the point P and point Q. We have used the angular speed. Now we haven't used the conservation of energy. For sure that the last one we need to use conservation of energy in order to find the U in terms of A and G. So for this case, we need to find the relationship of P and Q first. Okay, so this is the relationship. No, this is the relationship. To be more precise, we have found X. X is A. Okay, so consider the angular speed. So we have the VP over the since the X is A, so it will be 2A equal to the VQ divided by the A. So which means that the VQ is always the half of a VP. Okay, so when the VP equal to U, then the VQ will equals to half U. When the VP is equal to the 2 third AG, then your VQ will equal to third AG. So this is what we have. Conservation of energy. So right here you can see that for the Q, for the Q itself is moving up. So for the Q itself, when you move up, your GPE of Q gain. That means what? That means the KE of Q loss. And for the P itself, if we move this way, your of P loss, then the KE at P will gain. So this is the relationship. Okay, this is the relationship. What we can do is, what is the GPE of Q? GPE of Q is the MGH. The H will be A. You're going for 60 degree, right? You're going for 60 degree. Maybe I draw the diagram here. This is the A. This is the 2A. 60 degree. 60 degree. Yeah. Okay. So your GPE for the Q, the height that is gained is a GA. MGA cos 60. Then the KE of B gain is the V square. There will be 2 sub AG square minus a U square. Then it's equals to the KE loss. KEQ loss, it will be half M KEU. That means the initial velocity minus the final. The final one will be sub AG square plus the GPE gain. This one is 2A cos 60. 2A cos 60. MG 2A cos 60. Okay, simplify it. I will get half MGA plus the half M 4AG minus a U square half M U square over 4 minus the AG plus the MGA. So cancel all the M first. I have a half GA plus the 2AG, 2AG and 2GA same. 1 over 8 U square minus a half AG plus the AG. Okay, so we join together. You get this one as the 5 over 8 U square. And all the AG join together. 3 AG, 3 AG. Wait, Okay. Wait, AG AG plus AG. Yes, AG plus AG. I have 2 AG. So your U square will be the 16 over 5 AG. Then the U will be equals to the 4 square root of AG 5. Okay, that will be the answer already. Of course, you can simplify it, make it become 4 sub 5 AG over 5 if you want to, but I don't think it's needed. You can just leave it as a 4 square root of AG over 5. So I think I leave it the answer like this will be good enough. That will be the answer for the U in terms of A and G. Okay, move on. Oh, done. So this will be the last questions for this paper, I'll stop the video here.